Welcome back. In today's lesson, section 3-2, we're going to talk about representing functions. So, to get started, we need to recall what a function is. Remember, a function is a relation in which each element of the domain is paired with exactly one element of the range. So, if it helps remember the Archer story, 2 arrows can go to one spot, but 1 arrow cannot go to 2 spots. So that is going to be a key element in this section. So determine whether each relation is a function. So let's start off right here. The x's, we have -4 going to 9, -1 going to -6, 1 going to -6, and 3 going to 4. Would that be a function? Yes, it would, because even though -1 and 1 both go to -6, remember 2 arrows can go to one spot, and that is okay. Next one, -3 to 6, 2 to 5, 3 to 1, and 2 to 4. So would this be a function? Our answer would be no, because of right here, 2 goes to 5, and 2 also goes to 4. Cannot happen that way. Okay, and one more. We have the function -2, 4, 1, 5, 3, 6, 5, 8, 7, 10. So notice none of our x's repeat, so this would be a function. So there we go. All right, let's move on. Vertical line test. Now, sometimes if we're looking at a graph and we want to determine if it's a function, we need to be able to tell if it's a function without having to look at every single point. So we have what we call the vertical line test. So what the vertical line test says, that if we draw a vertical line at any point through the graph, we should only hit one spot on the graph. So notice, no matter where I draw a line on the first one, I will only hit one spot. On the second one, which is not a function, if I were to draw a vertical line right through there, I hit 2 spots. I'd pass the function or the graph in 2 different spots, so that would make it not a function. And then this one, the last one, we have, it's called a split piecewise function. Notice there are 2 different spots where I'd hit, but they're not on the same line. Okay, even if I go right down the y-axis, it seems like I hit 2 spots, but that open circle means there's nothing there, so I miss it, and I only hit the bottom part of the graph. So that is a function. So we can use the vertical line test to help us when we're looking at graphs. So now, determine whether 2x minus y equals 6 is a function. So I'm going to use a t-chart. So I'm just going to plug in some variables. So if I plug in 0 for x, I get 2 times 0 minus y equals 6. Well, 2 times 0 is 0, so I get 0 minus y, which is just negative y. So I have negative y equals 6, which would give us -6. And then if I put in 0 for y, I have 2x minus 0, which is just 2x. So 2x equals 6. Solve for x, I get 3. So now I have 2 points that I can graph. So I'm going to go to 3, 0. And I'm going to go 0, -6. I'm going to scroll down a little bit. Okay, so there is my line, my graph. Now, if I were to draw a vertical line through anywhere, do I hit more than one spot at a time? And the answer is no. So, yes, it does. All right, next one. Let's look at it. Determine whether x equals -2 is a function. So let's make another t-chart for ourselves. So if we have x, we have a y. So if we put in, let's say, -4 for y, what is x? Well, it tells us x is -2, no matter what. If I put in 0, I get -2. If I put in 1, I get -2. I could put in a billion, and x would be -2 because it tells me x is -2. So I just go to those spots, -2, 0, -2, 1, and -2, -4. So it appears I have a completely vertical line. Well, if I draw a vertical line through my vertical line, well, obviously I'm hitting more than one spot, so no, this is not a function. Vertical lines are not a function. So now we have what we call function notation. So notice the equation y equals 3x minus 8, and the function notation of f of x equals 3x minus 8. So notice, if we look at something very closely, but before we do, just notice this is said f of x. F of x is how it's pronounced. F of x. It's just a name. Okay? F is not a variable, it's just a name. So when we use, if we use some substitution, we can see that f of x is just equal to y. Okay? They are the exact same thing. Okay, f of x and y are the exact same thing. So it's just a fancy way of writing y. So what it's going to do is help us to substitute in. So let's do a few examples before we finish up today. So f of x equals 2x plus 5. So wherever there's an x, I'm going to put in 2. So I'm going to plug in a 2 there. So it stays f of negative 2 equals 2 times negative 2 plus 5. And I'm just going to do my simple math. So I get negative 4 plus 5, and that is just 1. On the next one, I'm going to put in a 1 wherever there's an x. So I get 2 times, well, let's put x again. I forgot to take my x out. 2 times 1, and then plus 5. But then I got this plus 4 I got to bring with, because it's adding on to the function itself. So I get 2 plus 5 plus 4. So I get 7 plus 4, which just gives me 11. Alright, let's keep going. Get rid of that shade, we don't need that. So f of 3. So I got to remember my function here. That's just right here. Well, technical difficulties. Yeah, 2x plus 5. Just so I don't forget here. Alright, so now I'm going to put that 3 in exactly where that x is. So I get 2 times 3, and then I'm going to add 5 at the very end again. So I get 6 plus 5, and then 6 plus 5 is just 11 once again. And the last one on this page, we have 2 minus. Now notice that 2 minus doesn't do anything. It isn't a part of the function itself, so I just bring it with. And then f of 0. So, but now I'm substituting in, so I got to put in parentheses. 2 times 0 plus 5. So 2 minus, well, 2 times 0 is just 0 plus 5. 0 plus 5 is just 5. So I get 2 minus 5, which just gives me negative 3. There we go. So let's do a couple more, a little bit more in-depth, a little bit more tricky, but I think you can handle it. Okay, so if f of t is equal to 2 to the t to the third power, find each value. So again, nothing is going to change for us. We're still going to substitute. Now this is using t, so we're still just going to put in that 4 wherever that t is. So I get f of 4 is equal to 2 times 4 to the third power. So now we follow PEMDAS. Parentheses, can't do anything on the inside, it's just 4. Exponents, 4 to the third power would just give us 64. So I have 64 times 2, which is 128. Alright, and the last one. Notice it's just 3 times f of t. Well, we know what f of t is. F of t is the original itself. So I have 3 times 2t cubed. Well, there's nothing I can really do except for multiplication. I can do 3 times 2, which is just 6, and I'm left with t cubed. So my final answer is just 6t cubed.